Hello everyone. On this video we will be looking at compound interest. Now with compound interest you have two different types. You have the ones that are compounded a couple of times per year, and you have the ones that are compounded continuously. So we'll be looking at both of them. Okay, so first we're going to look at the compound interest that's compounded a few times a year. Okay, so compound interest is just the interest that can be made on the initial money that's loaned or invested over, and the money that adds up over it, over a certain amount of time that we will call T. Okay, now in this case we're going to let our A, or our A of T, equals the amount after a certain amount of time, or T units of time. Okay, we're going to let our principal be our initial or our starting value. And our T is equal to time in years. Our R is the annual percentage rate. And remember, whenever you have your R value, you're going to convert it to decimals. And N is equal to the number of times that the value of the loan is, or interest rate, is compounded every year. Okay, so to give you an example of what that N could look like, I'm going to go ahead and scroll up. So if you're still writing, feel free to pause and finish all that up. Okay, so if your problem says it's compounded annually, then your N is going to equal 1, because annually is just once a year. But if it says it's compounded semi-annually, then that's twice per year, so your N would equal 2. If it says quarterly, then that's 4 times per year, and your N will equal 4. If it says monthly, then it's compounded 12 times per year, and your N will equal 12. If it says weekly, which is 52 times per year, then your N will equal 52. Okay, so sometimes they will give you the N value, and sometimes they'll give you one of these terms where you have to figure out which one of these N values it will equal. Okay, and your compound interest formula is A of T is equal to our principal, P, times 1 plus our interest rate divided by N, which is one of these N's here, to the power of N times T. And that's your compound interest formula. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and jump into our first example. Oops. All right. So let's say if we invest $3,000 in an investment account paying 3% interest compounded quarterly. How much will the account be worth in 10 years? All right, so for this one, okay, so our starting value is 3,000. So our P will equal 3,000, which is our starting amount. Our interest rate, which is 3%, will be 0.03, because remember 3% is 0.03, which is your interest rate. Our T will equal 10, which is 10 years. Our time in years. And our N will equal 4 because it's compounded quarterly. All right, so we know that our formula, A of T, is equal to our principal times 1 plus R over N times N to the power of T. So since our T is equal to 10, this means that our amount after 10 years is equal to our principal, which is 3,000, times 1 plus our interest rate over n, so 0.03 over 4, times the exponent, n times t, so it's raised to 4 times 10. Okay, so we can go ahead and simplify in here, so that means it'll equal 3,000 times 0.03 divided by 4 is 0.0075, so 1 plus 0.0075 is just 1.0075 raised to the 40th power. Okay, so if you plug all of this into your calculator, you will get approximately $4,045.05. And you always round it to the nearest, unless they say otherwise. But just in general, you will round it to the nearest pennies. So it may be 0.05, blah, 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 blah. It's just 0.05 because you can't get a portion or fraction of a penny. So you just round it to the nearest penny. Okay, so what does this mean? That means the account, let me raise this up, sorry about that, will be worth $4,045.05 in 10 years. All right, so if you are still writing this, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay, so it says a woman wants to invest money into a tax-free college savings account for her granddaughter. She wants the account to grow to $40,000 over 18 years. If the account has a 6% interest rate compounded semi-annually, then how much needs to be invested in the account now? And of course, we want to round to the nearest dollar in this case. All right, so what I want you to do is go ahead and press pause, and using the same method on the previous example, try this one on your own. All right, so I'm assuming you've paused and worked this out, so let's go ahead and verify. Okay, so you can start with any of your variables. So our R is 0.06, because remember that 6% is 0.06 when you convert it to decimals. Our T is equal to 18, because that's over 18 years. Okay, and our N is equal to 2, because we know it's compounded semi-annually. Okay, now the amount, we actually know that value. We're not solving for this. We know that value. That amount is $40,000, because that's the amount after T number of years. Okay, now our starting investment, or our starting value, is what we're solving for. Okay, so this is our initial investment. Okay, so just like before, we're going to plug everything in. We have A of t is equal to our principal times 1 plus r over n to the power of n times t. Okay, so our amount, our A of t, is 40,000. So we replace this with 40,000, which is equal to our principal, which we do not know, times 1 plus 0.06 over 2, our r divided by n, to the power of n times t, so that's 2 times 18. Okay, so that gives us 40,000 equals our principal, and 0.06 divided by 2 is 0.03. So 1 plus 0.03 is just 1.03 to the 36th power. Okay, so if we divide both sides by 1.03 to the 36th power, we get P is equal to 40,000 divided by 1.03 to the 36th power, which if you plug all of this into your calculator, you will get about $13,801. Okay, so we know that she will need to invest $13,801 to have 40,000 in 18 years. All right. So if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on. And this is continuously compounded interest. Okay. Now, when interest is compounded constantly, so it's not just compounded once a month or once a week or twice a year. It's compounded constantly. Every minute, every second of every day, it's compounded little by little by little at a steady rate. This is continuously compounded interest. Now, similar to the regular compounded interest, our P is equal to our principal, which is the initial value. The R is our interest rate that we will convert to decimals. The T is still the time in years. And the A of T is still the amount after T units of time. Now, the only difference is the formula. Our A of T is equal to P, our principal, times the value E to the power of RT. Remember, E is not a variable. E is an actual numerical amount. Okay, so plug that E into your calculator, to the power of RT. Okay, and that's if the value is growing continuously or your R is greater than 0. Now, if you have A of T equals P times E to the power of negative RT, then that's if your value is declining continuously. Okay, so you use positive RT if it's growing continuously, and use negative RT if it's declining continuously. All right, so if you're still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay, so let's say if a person wants to invest $100,000 at 12% annual interest rate, compounded continuously, what will the value of the investment be in 30 years? Okay, so we see here, just because it says compounded continuously, we're going to use A of T is equal to our principal times E to the power of RT. Okay, so we can see here that it's growing at a 12% rate. Okay, so we see that our principal is 100,000, which is our initial investment. Our interest rate is 0.12 because 12%. Uh-oh, 0.12. There you go. And our t is equal to 30. Time in years. There we go. Okay, so now we just plug everything in. Our A of t is equal to PE to the power of RT. So that means after 30 years, it's going to equal our principal. Let me write the actual principal in, which is 100,000 times E to the power of 0.12, which is our R, and 30. Okay, so you plug in E to the power of 0.12 times 30, or you find out what 0.12 times 30 is. E to the power of that value, then multiply that by 100,000, you get approximately $3,659,823 after 30 years. Uh-oh, sorry about that. Thought I raised it up far enough. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so we know that a car was valued at $38,000 in 2007. If it is continuously depreciating in value by 6% every year, how much was it worth by 2017? Okay, so you see here it's continuously depreciating. Okay, so just give you a hint. If t equals PE to the negative R times t, because whenever it's getting, the value is declining or getting smaller and smaller continuously, use negative RT. So what I want you to do is press pause and solve this one on your own. All right, so I'm assuming you paused it and worked it out. So let's go ahead and verify. Okay, so we know that our principal, our starting value, is 38,000. Okay, our interest rate is 0.06, because remember that 6%, 0.06, you just move your decimal twice to the left. Our t is equal to 10 because we're going from 2007 to 2017. Okay, so our t is equal to 10, which is our time in years. Okay, so our amount is equal to our principal times e to the power of negative RT, since our value is declining continuously. Okay, so that means that after 10 years, it's going to be 38,000 for our principal times e to the power of negative 0.06 times 10. All right, so if you plug this into your calculator, you will get approximately $20,855, which is how much it is worth after 10 years. All right. So hopefully this made sense, and I will see you on the next video.